Hello everyone, welcome to my channel. So today in this video I'm going to discuss another type of sorting algorithm which is bubble sort. So this bubble sort technique is used to sort a list of elements. The main target of this bubble sort algorithm is to send the largest element to the end of the list. So let's see that in detail so you will get a clear understanding of what is actually done by this bubble sort. As the first step, we have to divide the list into two sublists, which is sorted and unsorted. And the blue line depicts the wall between sorted part and the unsorted part. As the next step, we bubble the largest element of the list from the unsorted list and move to the sorted sublist. See, this was the original list of array. Okay, there the largest one was 78. So in here the 78 has come to the end. That means the largest element of the list has bubbled to the end of the list, and that part was called as sorted part, and the other things were unsorted because it is actually unsorted. It is not in order. And the next step is, after that the wall moves one element backward. You know, this is the wall. The wall was here and the wall had moved one element backward, increasing the number of sorted elements and decreasing the number of unsorted elements. Previously, number of sorted elements was 0, now it is 1, and previously number of unsorted elements were 6 and now it is 5. In here, what we done was we send the largest element to the end of the list. And also there's another method, we can move our smallest element to the beginning of the list, making the first part sorted and the rest unsorted. So by the efficiency part of view, it makes no difference. We can do both. Okay, now let's try an example and try to understand this process very clearly. This is the original list, and in here we are going to discuss the first pass of the bubble sort. That means how to send the largest element of this list to the end of the list. Okay, let's see. First of all, we compare the first two elements, the elements of index number 0 and 1. In here, this is not in order, like 7 is greater than 2. So we have to change these two, like it is in ascending order. Okay. Now when it comes to the second list, here 2 has come here and 7 has come here. Okay, the next step is comparing other two elements. That means index number 1 with index number 2. In here, it is in order, like it is in ascending order. Okay, so there's no need to change. So it comes as it is to the next step. In this part, we compare the index number 2 and index number 3. In here, it is not in ascending order. So we have to swap these two. That means 8 comes here and 12 comes here. In the next step, we have to swap the index number 3 and index number 4. So 12 and 3 is compared and 12 is larger than 3, so it must swap. So 3 comes here, 12 comes here. Now you can see that 12, the largest element, has come to the end of the list. Now this is the sorted part, this is the unsorted part. Now we have no use of this sorted part, we have to sort this. So we take this here, and this part depicts the second pass. That means now we are going to send the next largest to the end of the unsorted part and add that to the sorted part. Okay, let's see. In here, first two was 2 and 7. So it is in order. So no need to change. So it comes here as it is. 2 comes here, 7 comes here. And the next 2 is compared. It is also okay. That means 7 is less than 8. So it is in ascending order. So no need to change. Okay. They comes as it is. Then the next two elements are compared. But there's a problem here. 8 is greater than 3. So they must be swapped. So 3 comes here and 8 comes here. And the whole comes one element backward. So 8 will be a part of the sorted part. So these two are the sorted part. This is the unsorted part. Now we have to sort this part. So let's go to the third pass. Right. In the third pass, we compare the first two elements. This is okay. This is in ascending order. 2 is less than 7. So it comes as it is. Right? Then we compare the next two. Okay. In here, the next two was 7 and 3. And 7 is larger than 3. So they must be swapped. So 3 comes here. 7 comes here. And the whole moves one place to the front. So that 7 will be a part of sorted part and 2, 3 will be remaining in the unsorted part. So next we have to sort these two. Okay, let's go to the fourth pass. Okay, in the fourth pass we have only 2, 3 in unsorted part. So there will be only one swap. If there is a possibility to change, there need to be done only one swap. So we compare 2 and 3. This is already in ascending order. Okay, 2 and 3. So there will be no any change, and 2 comes here and 3 comes here. So these two are again in sorted array. Okay, we know that if a single element is already sorted, so we can take this as our sorted list. Okay, right. Let's see the sorting algorithm now. This is the bubble sorting algorithm. So I'm going to explain only the first pass. That means this part, how this 12 comes here to you. So you have to raise the other parts. Okay, so you can get a very clear idea about how this sorting algorithm works. Okay, let's see. This is the algorithm, and we take the array to our algorithm. And in the first place, it has int n equals arr.length. Arr is our array name. And we take the size of that array and store it in the variable n. So in here, I take this as an example list. So it has 1, 2, 3, 4, 5, 6. So n will be 6. Array length will be 6. So n equals 6. Okay, let's go to this for loop. In here, the first I will be 0. So I write it as I equals 0. Okay, then let's go to the inside. And the inside for loop, j will be 1. First. In first iteration, j will be 1. So I write it as j equals 1. Okay. Then there's a if condition. They say if arrj less than arrj minus 1, do this code. Do this part of code. Okay. This part of code is the code which we use to swap. In my earlier videos, I have explained how to swap two adjacent elements using a temporary variable. So I will show you that link in here in the upper part of the video. So let's see if let's see this condition. In here, ARRJ, we know that J equals 1. ARR1 is 78. We know that this is 0, this is 1. That's how we index now. Right. This is 0, this is 1. So ARR1 equals 78. ARRJ minus 1. That means 1 minus 1. It is ARR0. So it is 23. Okay. This is 78 and this is 23. Is it correct? Is the condition correct? No, right? That means 78 is not less than 23. So, there is no swapping. There is no swapping. It comes as it is. Okay? Right. So, no change. Okay. Then this if part will not work and it comes again to this inner for loop and j will be increased by 1. Now j is 2. This condition is also correct because this is 6. 6 minus 0 is 6. J is 2. So it is already less than what? 6. Okay. Okay. Now it again come to this if condition with the j equals 2. J is 2 and ARRJ is 45. Okay. ARJ minus 1 is j minus 1 is 2 minus 1. 2 minus 1 is 1. ARR1 is 78. Okay. In here, but this is a plus point. Like 45 is less than 78. Yes, 45 is less than 78. So this code part will work and swap the 45 and 78. This code part is used to swap the two adjacent elements. Okay. If you look this very clear, you will get a clear understanding if you watch that video. Okay. Right. Now, previously 78 was here, 45 was here, but now it is swapped. Okay. Now let's go to part. Now this will be exited from here and j will be again increased by 1. Now the j value is 3. Okay. This condition is also correct. J is less than 6. Okay. Now there is another if condition. Now in here ARR3 is 8. ARJ minus 1, that means 3 minus 1, it is 2, it is 78. Of course 8 is less than 78. Yeah, it is 8 is less than 78. So this code part will execute. Therefore 8 and 78 will be swapped. Okay. So it will be updated like this. 8 comes here and 78 comes here. Okay, now it will exit from this if part and it will go to the next iteration. It is j equals 4. Yes, 4 is less than 6. So it again go to this if condition. In here ARRJ. What is ARRJ? ARR4. What is ARR4? 0, 1, 2, 3, 4. It is 32. ARRJ minus 1. ARR 4 minus 1, it is 3. What is ARR3? 0, 1, 2, 3, 17. Of course, 32 is less than 78. This condition is true. So that this code part will be executed. So, the 32 and 78 will be swapped. Previously, it was like this. Now it is 32 came here and 78 came here. Okay. Now it comes out of this if loop. If condition and it goes to the next iteration. Now the j equals 5. Okay, right. When j equals 5, ARR5. What is ARR5? 0, 1, 2, 3, 4, 5. 56. What is j? J minus 1? 5 minus 1, it is 4. Yes, 78. We know that 56 is less than 78. Therefore, we have to swap because this if part is true, so this part will execute and it will swap the two adjacent element which is 56 and 78. Okay, and newly updated part is this list is this. 56 was here earlier, 78 was here, and now they have been swapped. Okay, now let's go to here again. In here, now j equals 6. But the condition is j must be less than 6. So this is false. So this for loop will be exited. Okay. At the end of this part, we can see that our first pass has been completed. That means the largest element has come to the last place, 78. Okay. This is the first pass. So you have to trace the other passes and complete this sorting. Okay, right. I hope you got what is the technique used in bubble sort. So let's see uh, another video of sorting algorithms in our next video. Okay, thank you very much.